Welcome to the Little Theatre. My name is Craig Slattery. I am going to act as MC and one of the speakers here tonight. It's an absolute pleasure to be here. This is fast becoming an annual event during our Science Festival in the Little Theatre. We had an event here last year. It was a fantastic event, very, very enjoyable. And we hope that you enjoy tonight's event just as much as last year's audience enjoyed theirs. So tonight we're all about all things sleep. You're going to hear from 3 different speakers talking about 3 different angles and ways of looking at sleep. And I'll introduce everybody in a moment. Before we really kick off, though, I think we need to acknowledge and salute the staff and the team from Midlands Science who are responsible for running and organising and planning the Midlands Science Festival. They have this week, this is their last event. You'll see them all slumping and falling asleep, hopefully, in the front row down here. They have run 130 events this week in the Midlands region, all based around different types, different flavours of science. They have brought this science to schools, to libraries, to every sort of public venue, to children, adults, people of all ages, sizes and shapes, and they have engaged thousands of people in science, and I think that deserves to be acknowledged. And a round of applause, please. So as I've said, this is the final event of Science Week, and I suppose the plan for this is to give you different impressions around sleep and different ideas and thoughts around sleep from different perspectives. So I'm going to introduce my partners in crime up here on stage, Dr. Silke Ryan, who is a consultant a nephrologist, not at all, a respiratory consultant in St. Vincent's Hospital. Silke is also a researcher associated with the Conway Institute of Biomolecular and Biomedical Research in University College Dublin, where she runs research programs looking specifically at sleep apnea. And Silke is a world leader in the area of sleep apnea, and we're delighted and honoured to have her here to speak to us about sleep apnea during tonight's event. Besides Silke, we have Dr. Ann Marie Craven from the University of Limerick. Ann Marie is a psychologist, practicing psychologist, and she's also a lecturer in psychology, and she is a researcher in psychology. She runs a research group down in the University of Limerick. And her area of interest, as she will tell you, is around looking at the relationship between sleep and lack of sleep and our mood and our ability to deal with stress and aspects relating to our psychological well-being. For myself, I'm a biologist. I am a biomolecular scientist, a biomedical scientist. And more specifically, I'm a pharmacologist. So I'm interested in how our body senses the environment around us, and then when it receives certain signals, how it processes them and translates it into a biological response. And I'm going to talk a little bit about the biology of sleep and how, when we get certain cues from the environment, how our body reacts to them and how it changes our physiology and our physiological state. I'd also like to acknowledge Burgess here at Lone. They gave us a wonderful window display to promote the event, and there was a prize put up as well. So it's fantastic to get local support when we're running these events. So I don't have many slides, but I thought it was worth putting this up because it speaks volumes. Sleep is one of the truly universal, one of only a few truly universal experiences that human beings have. Every human being on the planet needs to sleep, and every human being that has ever lived presumably needed to sleep as well. What that universality has done is made every person on the planet hate this sound. There's a unique response to that sound. My own heart rate is slightly, I get a shiver down my spine. We all hate the alarm clock. And that's because modern society has us all slightly sleep deprived, and we'll talk about that later on. So it's a truly universal event, sleep. By the age of 25, the average human being has been asleep for 10 years. Okay? Or has slept for 10 years during that 25 years, shall we say. Some people have been asleep for 10 years. In a normal human lifetime, the average human being will sleep anywhere from 25 to 30 years. Almost a third of our lifespan we spend unconscious. So straight away, without any more information, what that tells us, what the biology tells us is that this period of our day, this sleep event, is fundamentally important for our existence. If you add on top of that the fact that the drive to sleep, the biological urge to sleep, is one of the most powerful ones that we experience as human beings, we have very, very little conscious control over that urge. Just think about a time when you really wanted to go to sleep, you felt you needed to go to sleep, but your mind and your body wouldn't let you. Or then think of the reverse situation, probably more common for most of us, when you're trying to keep your eyes open, but your brain and your body are telling you it's time to sleep. So we have very little conscious control over that. And then the nail in the coffin, as far as I'm concerned, a normal human deprived of sleep will die from sleep deprivation quicker than they will from food deprivation. Okay? And we know this from various experiences and from various observations and tragic cases that have occurred. So all of that together tells us that sleep is not what a lot of people believe. It is not just an off position. It is not just a period of inactivity where the body shuts down for a period of time and nothing happens. There are really, really important biological processes going on while we're asleep, which are absolutely essential for our continued survival and health. So how do we think of sleep, or how do we define sleep from a biological perspective? So there used to be this perception and belief that sleep was this off mode. It was a shutdown, and we'll talk about the various reasons why you might shut down the body or why it was thought in a little while. But really now what we think about sleep is that it is an altered sense of consciousness. So it's a normal part of our day, a normal part of our biological rhythm. We'll talk about that in a moment. And it just happens to be a part of that rhythm where the conscious part of our brain is disengaged. So it's not that our brains shut down, that the activity falls off. It's just that the consciousness is disengaged for a period of that during our 24-hour cycle. And that cycle is very, very important for every biological organism on the planet, for mammals, for plants, microorganisms even. We see this rhythm, this biological rhythm, changes in the biology of organisms over a 24-hour period. And again, the 24 hours is common across most species. And that's probably because we're all sitting on the same rock, circling around the same sun. So it's probably from an evolutionary basis. We call that a circadian rhythm, from two Latin words, circa and diem, cycle of the day. And that's literally what it is. Over this 24-hour period, our body has evolved to synchronize different biological events and to organize our biology. And from an evolutionary point of view, that's a good idea because it allows for specialization, it allows for efficiency. It means that different parts of the body don't have to do their job all of the time. It means that if you have a way of controlling and synchronizing and intersecting the things that are going on, like your metabolism, like your heart rate, like your blood pressure, you can regulate it in different ways at different times of the day. And it's division of labor, effectively. So obviously, if we have that biological rhythm and we have that cycle, this circadian rhythm going on, our bodies have to have some way of keeping track of that. And that's down to a very specific brain region called the suprachiasmatic nuclei. And we'll call it the SCN for simplicity. It's a very specialized group of neurons in your hypothalamus, in your brain. And we now know that these cells, using genetic components, which we're scientists, we're not very imaginative, we call them clock genes, they can keep track of time. And they can do this in the absence, to a large degree, in the absence of external stimuli. So you can put somebody in a darkened room 24 hours a day, and this rhythm is there. This rhythm happens. You have like an internal clock inside your SCN, which keeps track of where your body is in the 24-hour period. Like every clock, your SCN can run fast or run slow from time to time. And it gets rectified by other signals. So the SCN, while it can take over and it can keep things going regularly itself, intrinsically, but these genes, it does use outside stimuli to right itself occasionally. So light, we know, is a very good stimulus and correcting factor. So when light comes into your eyeballs and interacts with the receptors at the back of your eye on your retina, a signal goes into this SCN that tells it it's daytime. And we have evolved, as a species, we have evolved to be most active and up and doing things when it's bright. So that's a stimulus that the SCN uses, light. It also takes input from other factors, chemical factors. And what we call those are sleep inducers or sleep pressures. So light is a stimulator. It wakes us up. But there are other things that the SCN can measure and keep track of that will cause us to move towards sleep. So one example is a molecule called adenosine. Adenosine is a byproduct of our normal metabolism. So in our body, when we eat, we extract energy from that food. We break it down, the more complex carbohydrates are broken down to simpler sugars, glucose, and we use that then to create a molecule called ATP, adenosine triphosphate. And that's the unit of energy currency in the human body. When our cells want to use that energy, they have to break up that ATP molecule, and a byproduct of that is an adenosine. So in our brains, we have got receptors that detect adenosine. The longer we're awake during the day, the adenosine, as we burn energy and our brain cells use it, the adenosine levels increase. And that's a very strong signal to our SCN that we've had a long period of wakefulness and we should start to think about moving to sleep. All right? So different ways our SCN keeps track. And the SCN is ultimately the master switch, the master controller of the transition from wake to sleep. When it wants to move us from sleep to wake, it causes signaling molecules in our body to be stimulated and upregulated or increased, like cortisol. And then cortisol causes an increase in adrenaline and other stimulatory signalers. And that gets us up and moving. So during the day, we have high levels of cortisol as a result of our SCN. As the day comes on, and all these signals telling the SCN we've been awake all day and we need to go to sleep kick in, the SCN turns off cortisol and starts to turn on dampening signals like melatonin to try and turn down the brain and switch it to a sleep phase. Okay, so we have that transition from awake to sleep. And lots of the different signals and factors that the SCN uses to gauge where it is. So that's a little bit on the mechanics of how we sleep, how we transition. We have this part of the brain that keeps track of time and then over the 24-hour period transitions us between wakefulness and sleepfulness. What I think is a much bigger question in a way, because we haven't found the answer yet, is why we sleep. And why we sleep is something that people have been thinking about for thousands of years. The ancient Greeks, ancient physicians like Hippocrates and Galen, they all had their own ideas about why human beings sleep. Because it's not immediately apparent why it's a good idea to sleep. We're made of quite soft tissue. We're quite vulnerable. So the notion of going into a state of unconsciousness for 8 hours or 9 hours every 24 hours, it doesn't seem very safe. Particularly if you're thinking about predators in an African savanna where we evolved from. Okay, so it's not intuitive. There must be a reason why we sleep so much of our day away. And then there have been lots of ideas formed over the millennia or proposed over the millennia as to why that is. And there probably isn't one answer that's 100% the reason. It's probably aspects of each of the ones I'm going to outline. So I've mentioned the evolutionary basis, and that's probably one that holds least water. That sleep is purely just an evolutionary or product of the evolutionary process, that we have evolved to sleep when it's dark, because that's when a lot of the predators that would prey on people who have nice fleshy bodies, that's when they prowl. So this idea that if we sleep when they're most active, that would be protective from an evolutionary point of view. And it doesn't really make sense, because as we've studied animals in the wild, that relationship doesn't hold true. So, for example, the lion sleeps for maybe 16 hours of the day and then only hunts for a very short amount of time. And giraffes and other savanna animals that they might prey on only sleep for 3 or 4 hours in that same 24 hours. And they're active. They are still active when the lions are actually awake. And it would be much easier, to avoid the lions through sleep by synchronizing the pattern if that was what was really going on. So we don't think that's the main reason. Another proposal about why we sleep is for energy conservation. That it might have been a benefit as we were evolving that you shut the body down for 8 hours, 9 hours, you conserve energy because food is hard to come by. You have to go out and hunt, you have to collect, you have to prepare it. And then if you shut down and you can sleep and save energy, that might be an evolutionary advantage. And again, more recently, as we have, I suppose, figured out how to accurately measure energy in calorific use, what we know is that when we're asleep, we only use about 10% less calories, burn about 10% less calories than when we're awake. So again, that idea doesn't really hold up. It's not a huge saving. And again, the period of time, the amount of time that we sleep, it doesn't really justify that sort of a saving, or it doesn't hold up. Another idea, and again, this idea has been around for a surprisingly long time, and while the details may not have been right initially, so Galen came up with this notion that sleep is about restoring the body. And that what happens during the day is we effectively, all the energy as we live our lives flows out away from our vital organs like our brain and our heart. And that all goes out across the body, our vital energy. And then when we sleep, it gets sucked back in preparation for the next day so it can flow out. So, like I say, the details of that are wrong, but it's actually not a terrible idea. Sleep has restorative qualities. And we regard, from a biological perspective, we talk about sleep being a homeostatic mechanism. So a homeostatic mechanism, we have lots of them in our body. And all it means is bringing things back to a balance or bringing things back to a center point. So there is that aspect with sleep. Adenosine is one aspect of that. So as you're awake, you're burning energy, you're building up this byproduct in your system, the adenosine, and then when you sleep, the adenosine is able to get reabsorbed and cleared from the system. Equally, wound healing. When we're asleep, we heal wounds and damage to our muscles and our tissues far more efficiently than when we're awake. Our immune system is far more active at night time than it is during the day. So if we have an infection, when we sleep, a lot of the fight against the infection takes place during our sleep cycle. So there is this restorative aspect to sleep. But again, you could do some of that when you're awake. Why are you taking this big chunk of your day unconscious to restore and bring things back to a balance? And it's only really since the 1950s that we've gotten into the heart of things. And that is when it was recognized that, I'm going to skip on to this one, it was recognized that there is a huge amount of brain activity when we're asleep, when we're unconscious. So through using a method called EEG, electroencephalograms, which is effectively putting little electrodes on the skin of the head and measuring electrical activity, you get an idea of how active the brain is during a sleep portion. And contrary to what was believed previously, where we thought the brain went offline, there are periods of intense activity during sleep. And that has led us to a picture of what happens when we go to sleep, and it's called the different phases of sleep. I'll talk about those in 1 minute. What we know is that sleep is very, very important for memory. So as we go through the day, we have lots of experiences. We may interact with people. Some of those experiences may be things that we want to hold on to, that we want to remember, and some of them may be trivial things that we don't want to retain. And what we now know is that during different phases of sleep, our brain starts to sort out memories by modulating electrical activity through different connections. Because that's what our memories are. They're connections between neurons, between brain cells. And the way that our brain marks out the memories that are to be reinforced and retained is through enhancing electricity and electrical signaling through those particular connections. And the ones that are to be lost, the trivial things, they downgrade the activity in those. And this all happens when we're asleep. So somebody said to me, it's a little bit like defragmenting a hard drive. If anybody's ever done that, you have to kind of take the computer offline. You can't use the computer when you're doing this kind of a thing. You're organizing the data on the hard drive. If you try to use it at the same time, it doesn't work. So maybe that's part of the reason why we have to take our brain, our consciousness offline to allow this processing to take place. So the different phases of sleep that we've now characterized. In phase 1 and phase 2, which is quite early in the night, it's called non-REM sleep. So REM is for rapid eye movement. I'm sure all of you have heard of Michael Stipe's band. So rapid eye movement is associated with a phase of sleep where your eyes are flying around. Your eyes are closed, but you can see the eyes moving under the eyelids. And that's rapid eye movement sleep, or REM sleep. And that's just one particular phase, phase 4 in the cycle. There are 3 other recognized phases where your brain is doing different things, which we call non-REM sleep. Phase 1 and 2 are, phase 1 is when, maybe some of you in here are going to start doing it. You start to nod off, and then you go up. Or maybe you imagine something, you go, what? So you can get hallucinations, you can get these shocks, and you come back up to the surface again. So it's just dipping into drowsiness. Phase 2, you're starting to descend into a deeper sleep. You're not fully asleep yet, but you're starting to go into a deeper sleep. And then phase 3 is what we regard as deep sleep. So difficult to awaken somebody who's gotten into phase 3 sleep. What we know is the restorative things that I talked about, most of those happen in phase 3. So that's very important for our immune system function, for our wound healing, things like that. And REM sleep then, it's almost like a switch goes off and we get this really intense brain activity, our eyes start to move, and lots of other things that we might talk about later on, like muscle paralysis, sleep paralysis, kick in during REM sleep. So, I'm almost out of time. The last minute, I want to run through some of the associations that we've now identified, because unfortunately, as I said at the start, the vast majority of modern societies are in sleep debt, or are sleep deprived on a chronic basis. So we don't get as much sleep as we should. And we know that sleep deprivation or chronic sleep debt is associated with an increased risk of diabetes, and it's also increased with an increased risk of weight gain and obesity. So regulating your metabolism, sleep is very, very important for regulating your metabolism and how you handle energy and how you deposit energy in your body. And the two of these obviously are linked. So obesity is a major driving factor for the development of type 2 diabetes. We also know, as I said, there's a large portion of the night when you're asleep that your immune cells are very, very active. And we know that the effectiveness of vaccination, for example, can be affected by how well you sleep the night after. Okay? Also, cardiovascular function, your heart and your lungs, not getting enough sleep, we know that that correlates very closely with cardiovascular diseases. And the one that I want to mention relates to memory. And this is a very, very recent discovery about the brain and what happens in the brain during sleep. And it links the memory aspect with the restorative aspect. So we're all familiar with Alzheimer's disease and how as we advance through life, there is an increase in this inability to make new memories and to gradually lose older memories. And one of the main causes in Alzheimer's disease, or one of the main driving causes, is thought to be the accumulation of a protein in the brain called beta amyloid. And beta amyloid is made in our brain normally, and it's normally deposited in our brain during our waking hours as well. And what has been discovered in the last couple of years is that this restorative aspect of sleep, during phase 3 deep sleep, your brain is 10 to 15 times more efficient at getting rid of beta amyloid, getting it out of your brain. So what that suggests is that over a lifetime, if you have a lack of sleep, you're going to have a proportionally reduced ability to get rid of this beta amyloid protein out of your central nervous system, out of your brain. And maybe that's going to increase your risk of developing Alzheimer's disease later in life. Okay, I think you've heard enough from me. So we're going to hold questions until after all three speakers have said their bit, because you might ask me questions that some of the other speakers are intending on answering anyway. After Ann Marie has finished speaking, we'll pull over the chairs and we'll have an open discussion. So hold your questions, and if any more crop up, make sure you put your hand up at the end. And thank you for your attention.
Now, good evening to you all, and thank you, Craig, for this very nice introduction at the beginning. And I just want to congratulate Midlands Science, and particularly Craig, for putting such a fantastic event together. It's immensely enjoyable, and it's a great pleasure for me to be here, and particularly to have such a great turnout from the audience. So I'm really coming from a very different angle here. So I'm a sleep physician, so I deal mainly with conditions which would lead to an abnormal sleep. And the one condition I want to talk about tonight is obstructive sleep apnea, which is a condition which is one of the most prevalent conditions in sleep, and also is now a condition which has really rapidly and quite dramatically evolved into a significant public health burden. So again, as Craig outlined, if you have any questions at the end, you can ask me certainly at our panel discussion. So I'm sure most of you agree in the reason that you're here, and Craig really outlined this very beautifully. Sleep is a really very attractive, very interesting, because also mysterious subject, and not really surprising that many people in art and literature have been equally fascinated by this topic and have portrayed it in all various different ways. This is just an example. This is the wonderful painting of the Sleeping Venus by Giorgione, and you see the various different aspects of sleep. I mean, it's very rested, it's a very peaceful approach, but at the same time, certainly this person is in a very vulnerable state. And although, as Craig outlined, we don't really understand yet the full biological function of sleep, we do know that sleep is highly essential. So if you deprive animals in the lab of sleep, they will all die, and the same would happen to us. And we certainly, and also Craig mentioned these figures, we spend certainly an awful lot of time sleeping, so it has to be good for something. A third of our life, 26 years. I figured it out, that is nearly 150,000 soccer games you could watch at a time. Now, for me as a big soccer fan, that seems to be a bit of a loss. Now, in comparison, we do spend about 4 years at a moment of our lifetime surfing the internet. So we're not quite there yet, although if I look at the generation of my kids, then I'm sure they will like to have that reversed very soon. But besides sleep being an essential function, we can't function without sleep. Sleep is also a really enjoyable activity. Well, certainly, I love it. I love to go to sleep. And it's a really wonderful experience. And there was a recent poll which was performed by The Guardian in the UK. And really not surprisingly, a good night's sleep was really voted as the greatest little pleasure in life. However, this is unfortunately not a reality for all of us, and this is particularly attributable to these aspects of sleep disorders. And sleep disorders are really all diseases that affect, disrupt, or involve sleep. So people may not actually think they have a sleep disorder, but something goes wrong in their sleep which actually affects daytime performance. And currently in the international classification of sleep disorders, we distinguish between 60 different sleep disorders in total. So it's quite a broad spectrum. We know now that at least 10% of the whole population suffer from a somewhat clinically significant sleep disorder. So it's a bigger problem than some people might think. And one of the main diseases really in this scenario is sleep apnea. And that's the one I'm going to talk about. So sleep apnea is really now a big problem in our society. So what is sleep apnea? And I just want to explain this a bit more in detail. This is a cut of the upper airways. So what you see, what you see here is the mouth with the tongue. This is the nose here. And in a normal person, so in a person who doesn't have sleep apnea, the upper airways stays nicely open during sleep. Okay, so air can go in, can travel down the throat, into the lungs, and that's where gas exchange is happening. And that's how it should be. However, in sleep apnea, you get a repetitive collapse of the upper airways. Generally, this is happening here at the level of the tongue. And what that leads to is a cessation of airflow. So the air cannot go down further into the throat. And if that occurs for longer than 10 seconds, then we call that an apnea. And the consequence of that is, so no air can go into the lungs, there's no gas exchange, so the oxygen level will drop in the blood. And that is ultimately being sensed by the brain. So the brain can always react to this. It's rarely that people don't have prolonged drops in the oxygen level. So the brain senses that. What the brain will do is it sends a little signal to say, okay, here's a problem, wake up. And that causes a very brief awakening, an arousal, as we call it in medical terms, which then restarts the breathing. And that occurs several times then during the night. And you can imagine that leads to a very fragmented sleep. So sleep, the cycle which Craig outlined with the light sleep, the deep sleep, and the Rem sleep, this is quite disturbed in sleep apnea. And sleep apnea is per definition defined if 5 of these breathing pauses, so they have to be at least 10 seconds long, occur per hour of sleep. So something which we call the apnea-hypopnea index. So more than 5 episodes per hour. So if someone sleeps 8 hours, that would equivalent to 40 episodes for the night. That is sleep apnea. Okay. Now, before the upper airways completely collapse, you get generally a vibration of the airway. Okay, and this is really the cause for one of the cardinal symptoms of sleep apnea, which is heavy snoring. Now, don't be afraid if you think, oh, I'm snoring at home, do I have sleep apnea? The vast majority of people who snore don't have sleep apnea. Snoring is a very common phenomenon. But what is quite typical for sleep apnea is the very loud, heavy snoring, snoring in any body position, and the one snoring which generally occurs at least most nights or even every night. And it is very often that the patient themselves, actually, they don't think there's any problem, but the bed partner is the one which is very annoyed. And very often people come to my practice, generally the man sits there, no, there's no problem, no problem. And the bed partner, dash wife, says, oh, hold on a second. He snores so loudly. He's not going to leave that room until you have him sorted. And it is really a problem. I mean, sometimes you have neighbors complaining about this heavy snoring. Bed partners may also witness these apneas. Now, this is variable, but quite often you get these periods when the snoring suddenly stops, right? And you have these periods of silence, which is sometimes even more annoying than this. And that is quite predictive then of actually the person truly having sleep apnea. So I'm just going to show you a little video clip. I hope this projects reasonably well of what this looks like in real life. Now, this is not a patient of mine. This is a YouTube video, but I show this actually a lot to my students. So you actually hear very little. I mean, you hear the sound of the computer, but you hear very little. And the reason for that is he doesn't breathe. Okay, so he lies there, has his mouth open, as it quite often is, but otherwise there's nothing happening. Now he tries to breathe. You can't see that really well, but his chest is actually keeping the rise. So the muscles are functioning, but the upper airways are closed and no air's going in. Now you hear the snoring starting, and you see he's moving around. So he's clearly in a somewhat awake state now, okay? So, and now another silence, okay? So that's when the next apnea starts. And in severe cases of sleep apnea, this is happening now several hundred times a night, okay? And it always astonished me still after years of practice that he gets up in the morning and he thinks there was nothing wrong at nighttime. He may even go to work, he may do a normal function, and he hasn't a clue that he was sleeping like this at nighttime. But you can imagine that is a really corrupt sleep. This is a superficial sleep, and hence, not really surprisingly, the most debilitating symptom of sleep apnea is excessive daytime sleepiness. And now this is a very variable symptom and doesn't really correlate very well with the severity of sleep apnea either. So quite often you have patients of very severe sleep apnea and they actually have no complaints whatsoever. They can function because they can learn to function on very little sleep. But in general, most patients would complain of being unrefreshed in the morning. They get tired during the day. They may even try to take a nap at lunchtime if possible. They fall asleep watching television. Now I do that all the time. And to the extent, obviously, then that people fall asleep in situations where they shouldn't fall asleep. It's actually a very classical scenario of looking for your patient in the waiting room because they're actually asleep and they don't hear you calling them. Patients might fall asleep during conversations. The worst patients I have ever seen was a gentleman who used to work in a fish and chip shop, and he had severe scarring of his hands because he just kept falling asleep and his hands dropped into the hot oil. It took him actually years before he realized that might not be normal, and obviously then he was diagnosed with very severe sleep apnea. What we certainly don't like to see is if patients fall asleep in these situations. And this is a true video of a patient with sleep apnea. He has a web camera in his car. Now, I'm not responsible for the sound, you know. But that's obviously something we don't want to see. And it's a big problem. Now, you may obviously see that he didn't wear a seatbelt, which is a different problem, but he clearly has fallen asleep. You don't want to be the driver. You don't want to sit in the back of his car, but you also don't want to be in a car which just by chance is at the same time at the same place at his car when it crashes. So the rate of road traffic accidents in people with sleep apnea is about 5 times higher than it is in people who don't have sleep apnea. So that's a really big problem for all of us, particularly for us physicians, obviously, who have to deal with it. So who gets sleep apnea? Well, literally, in theory, everyone can get it. Also in children, it occurs, but most commonly it is in middle-aged men. Now, there are certain people who can get sleep apnea more likely than others. So, and the most common predisposing factor for sleep apnea is just an abnormally small upper airway. Okay, so many people are genetically predisposed to have sleep apnea. They just have a small upper airway. And therefore, sleep apnea somewhat runs in families. In kids, particularly increased size of the tonsils can be a problem and can cause sleep apnea. My son, he had severe sleep apnea and he got his tonsils then removed when he was 4, and things were fine afterwards. It's less so an issue in adults. What you do get in adults is quite often polyps in the nose and so, and they can contribute to sleep apnea. So anything which can potentially obstruct the upper airways can contribute or lead to sleep apnea. However, the most common modifiable risk factor of sleep apnea by far is the presence of being overweight or obese. And this is such a strong association, and this is really where the whole public health burden of sleep apnea also arises. And the reason of why obesity is going to fit in there, it's particularly an increased fat deposition in the upper airway wall and also in the surrounding tissue, so in the neck. So and that compresses on the upper airway as well. So it doesn't cause sleep apnea, but people who are predisposed to sleep apnea and are obese are more likely than to get the condition. But there's also an important message in it, and that's not to forget, is that although it is a very common link, there's also a significant proportion of patients who are not obese. So it doesn't mean, oh, you're not fat, you can't get sleep apnea. The best case, or the real textbook case I have in this scenario, is a 17-year-old girl who is as slim, as fit as you can only think, but she actually has very severe sleep apnea. There's a lot of other predisposing factors. I don't want to get into it in great detail, but for instance, drinking alcohol in the evening, sleeping tablets, they also contribute to the condition. And that's because they slow down the reaction of the brain to the breathing problems, and hence they can bring on sleep apnea. Now, you might think that sleep apnea is a very new condition. It certainly only has gotten really great attention over the last few years, but it's actually around for a long, long time. And one of the very early descriptions of sleep apnea, really in a very beautiful fashion, is actually from Charles Dickens from the 19th century. He describes in his book, The Pickwick Paper, this wonderful fat boy Joe. Okay, and he's actually illustrated here in the back. Okay, so you certainly see he's a bit chubby, right? And where you see all the action here is in front and people are watching it, he is just soundly asleep and happy there. Okay, so in the whole book, all the passages about this wonderful fat boy Joe, if you read it, it's really beautiful, describes classical sleep apnea. And hence, for a long, long time, sleep apnea has been actually called the Pickwickian syndrome. It's a term which we don't use anymore, but this is really arisen from this book. So I mentioned already sleep apnea now a significant public health burden, and this is certainly in great part due to the fact that it's just so immensely common. We don't have any Irish figures, but a recent publication, which is from the US population, indicated that now 14% of middle-aged men, so this is 1 in 7, so we can count along, and also 5% of women, so also a significant proportion of middle-aged women, have now a clinically relevant sleep apnea. So the frightening picture is we only see at the moment the tip of the iceberg. Okay, there's so many people who are undiagnosed with this condition. And also frightening that this prevalence is continuing to rise. And this is really in parallel with the rising incidence of obesity and the really epidemic problem of obesity. So it's very, very common. But on the other hand, the public health burden and the problem is also arising from the many clinical consequences which can arise from sleep apnea. So patients are very sleepy in general, so you can imagine quality of life is impaired. It will lead to a poor work performance. I mentioned already the increased rate of road traffic accidents, also occupational accidents, about 3 times higher in sleep apnea than in people who don't have sleep apnea. And then there is this really massive problem of the cardiovascular diseases which are associated with sleep apnea. So sleep apnea is an independent risk factor for the development of numerous cardiac conditions. So things like high blood pressure, stroke, heart attack, heart failure, they all can follow from untreated sleep apnea. Sleep apnea is now also linked to the presence of diabetes and the control of diabetes. Even cancer has now been associated in newer studies with the presence of sleep apnea. So it is a significant problem which is arising from this condition. And hence, then really not surprisingly, people who do have sleep apnea are more likely to die early. So these are survival curves. This is again a study which is from the US. So basically, when you have a steeper survival curve, you're more likely to die early. So in black here, you would see a group of people, who don't have sleep apnea, and then with increasing severity of sleep apnea, you're more likely to to have decreased survival in comparison to other people. And it's adjusted for all other possible factors. So it's really an independent relationship. Now, after giving you all these bad news, the real good news about this disease, and that's something we just cannot say about many chronic conditions, is we can treat it. And we can treat it really well, okay? So, and the treatment is mainly dependent on this CPAP treatment. CPAP stands for Continuous Positive Airway Pressure, okay? And this is generally a mask which is worn at nighttime. It sits usually just over the nose, sometimes over the mouth as well. And it's attached to a machine, and this machine blows air into the upper airways, okay? So this air applies literally positive pressure. It's like a splint to keep the upper airway open. So the upper airways cannot collapse now. So air is going through, oxygen levels normalized, the brain has no work to do, sleep is normalized. And this really happens very easily with this principle, okay? And that's really what it looks in real time. Now you may know people who are on this treatment. Now there are numerous different ways of applying CPAP therapy, very different mask devices, but at the end of the day, they do all the same. These are, so just examples of some machine. They even come in pink now. But this is generally what it looks like. Now, you can imagine that for some people that can be difficult to get used to. It's not without problem, and you have to obviously persevere quite often the initial period of getting used to it. But generally, and when it works, then things become very easy, and people will feel the benefit of this treatment. It works instantly, right? So this is a very early study from the CPAP area. So CPAP was invented in the early 80s. And the guy who actually invented it, he was on his way home in a train, and he just put out a piece of paper and said, that should work, and he made obviously millions from it afterwards. He founded a company afterwards and developed this whole treatment. So this is an oxygen level in a patient with sleep apnea. Okay, so what you would like to see is an oxygen level which is here a straight line, and it's generally 93, 95%. It's measured by a little finger probe. Okay, and this is sleep apnea, right? So what you see here is these really frequent drops in the oxygen level. So then the oxygen level goes up again, it goes down again, and it's up and down. This is very classical sleep apnea. So this patient wears CPAP therapy, CPAP machine is being switched off, right? So sleep apnea starts, the machine is switched on again, and immediately this is getting abolished. So it works instantaneously, and not surprisingly, with such a treatment effect, you get an enormous improvement in the patient's symptoms. So the good news for the bed partner, patient will stop snoring. Now they may have to adjust to the noise of the machine, but that generally works, and bed partners prefer it as well. It will improve the sleepiness, and hence will improve the quality of life. Very importantly, it prevents road traffic accidents. So the rate of road traffic accidents on people who are on CPAP now with sleep apnea is similar to the one from the normal population. So what sleep apnea has caused in terms of road traffic accidents is being reversed by CPAP therapy. And we have a lot of indication now that CPAP also improves cardiovascular outcome. It improves blood pressure control. It prevents heart attacks and so on. So it's really a very important and very good treatment. Now it's a treatment, it's not a cure. It doesn't do anything about the origin of sleep apnea. It just prevents the upper airways to collapse. Has to be worn every night, but as I said, it's a very good treatment, which is also very safe to use, and that's not something we can say about every medication which we use in medicine. So it's really what I just wanted to summarize. So if you feel, or you know of anyone who may have the symptoms you're concerned about, what you should do in these scenarios is discuss it with your GP. I didn't go in any form about how to diagnose sleep apnea, but if your GP would be concerned, he would certainly refer them on to one of the sleep centers in the country and then certainly things can be taken from there. Okay, so I leave it as that, and as said, later on, you're very welcome to ask any questions.
Okay, thanks Silke, very interesting. So my name's Ann Marie Craven and I'm a lecturer in psychology and a researcher in the Department of Psychology at UL. So I also want to thank Craig for inviting me to come speak today, and particularly because now I've met Silke. So when I, reach an age where my airway starts to narrow, I know exactly who to call, okay? So at UL, my research interests are in health. So I'm interested in psychological processes that influence health, both your physical health and mental health. Now you might wonder, well, why is a psychologist interested in sleep? Well, we all know that feeling when we don't get a good night's sleep, of waking up the next day, maybe feeling a little bit cranky, maybe you're not the best person to be around that day, maybe you're not doing so well at work that day, and so on. So having a good night's sleep is associated with mood, it's associated with cognitive performance, and it's associated with mental health. So it makes sense that psychologists would be interested in sleep. Now, another reason why we might be interested in sleep is, as well as being a biological process, sleep is a behavior, it's something we do. And psychologists are interested in cognitive processes like thinking, like attention, like memory, but also behaviors, things we do. So there's lots of good reasons why psychologists are interested in sleep. Now, when psychologists study sleep, we probably don't have the same approach as a doctor necessarily. The first thing we might do is ask you about the quantity and the quality of your sleep. So psychologists will ask you, how many hours sleep are you getting a night? And do you feel refreshed when you wake up, or are you tossing and turning, and so on? Now, if a psychologist is interested in diagnosing a sleep disorder, what we might do is refer to a manual of psychological disorders that we have. Now, this manual has a very old-fashioned name. It's called the Diagnostic and Statistical Manual of Mental Disorders, okay? So I don't think mental disorders is the best word. I prefer psychological states, okay? But that book has been around a lot longer than I have, so that's what we're left with. So we're currently on the 5th version of that. So we call that the DSM-5 for short. And in that book, we have at the moment 10 different categories of sleep disorder. So we don't have the 60 Silke mentioned, but we have 10 categories. So to give you an example of one of those categories, one of them is insomnia disorder. So what would a psychologist say insomnia is? Well, you could all probably tell me, when you haven't had a good night's sleep, you're not happy with it, you say you have insomnia. So a psychologist would say insomnia is where somebody is unhappy or distressed about the quantity or quality of their sleep, and they feel this for at least 3 nights during a week and for at least 3 months, despite having had the opportunity to get good sleep. And that's important. So if you're working shift work, or if you are not really minding your sleep and you're not getting good night's sleep, that makes sense, okay? What's also important from a psychological perspective, and this differs from a biological perspective, is the insomnia has to be causing you distress. So you have to be put out about it. So you might have a friend who gets a lot less sleep than you, or a lot more sleep, and they're fine with that. And that's okay. So a psychologist isn't interested, okay, unless you're put out about the lack of sleep or the quality of sleep. So if you were to come to a psychologist about sleep, they'd ask you questions about how many hours sleep do you have, do you feel refreshed, and so on. And we know from studies that ask people about the quality and quantity of sleep and ask them questions about mental health that there is a very strong association between sleep problems like insomnia and mental health problems. Now, of course, it mightn't be good enough if we put our researcher hats on for me to just ask you, well, how many hours sleep did you get last night? Or what time did you go to bed at? Because if you asked me what time I went to bed at last night, I'm not sure I could really pin it to the minute, okay? So another method psychologists might use are to ask people to complete a sleep diary. So in that, you'll write down the time you went to bed. You might try and write down the time you went to sleep. And first thing in the morning when you wake up, you'll write down what time it was when you wake up. Now, one group of researchers use this method to study how sleep might help you cope with stress. So they got college students over a semester to fill out a sleep diary and to also rate stressful events that happened to them and their mood. So a stressful event might be something like doing an exam or a test, but it could also be something like being stuck in a traffic jam. And what they found is that the people in the study who had had a good night's sleep were much better able to cope with stress the next day. When students had had a good night's sleep and something stressful happened, it didn't really affect their mood. But when they'd had a bad night's sleep and something stressful happened, they had much more negative mood. So that is consistent with what we know about sleep quality and quantity. When you don't get enough or the right kind of sleep, it has effects on your mood, and that can lead to more significant effects for mental health. Now, that gives you a little bit of an idea about how psychologists might study sleep. But of course, it mightn't be enough to say sleep is associated with mental health. How do we know for sure that sleep problems are causing mental health problems? It might be that mental health problems are causing sleep problems, or something else might be causing both sleep problems and mental health issues. So really, to resolve that, we'd have to do an experiment. And that would mean that we would randomly assign maybe half of you here to a group where you get your normal sleep, so lucky you, okay? And then we'll take the other half and we'll restrict your sleep to 40% of your usual sleep. And happily, I was lucky enough to be involved in a study where we got to do this. So we recruited young, healthy adults and we randomly assigned them to have either their normal sleep or 40% of their sleep. Now you're probably wondering, okay, well, how do you know they only had 40%? Because if I was in that group, I might be trying to sneak a little bit more, okay? So I might sign up for your study, but once I got allocated into the bad group, you know, I might be trying to get those extra minutes and hope no one notices. Well, we had a few things in place. So first of all, they had to set their alarm for when they went to bed at the normal time, and they set the alarm to wake them up after 40% of their usual sleep time. They also got a text reminder to their phone, are you awake now? You should be awake, okay? And finally, because we clearly didn't trust them, they were fitted with a monitor, an activity monitor, that made sure that we knew that they were actually up and about and active, okay? So we could tell if they were sleeping. And to lessen the blow, the next day when we wanted them to come into the lab and do some tests with us, we paid for a taxi to collect them, okay? So we didn't cause any road traffic accidents in that study, okay? So when we brought these people into the lab the next day, this would allow us to determine if having less sleep is what's causing differences in mood and performance and so on. So we brought them into our psychology labs and we exposed them to different stressful tasks. So these would involve things like having to pay attention, having to do maths, and so on. And what we did find was the group who had their sleep restricted didn't perform as well, also didn't enjoy it as much, found it more stressful, and had poorer mood than the other group. So this kind of experimental study can help us confirm that poor sleep or a lack of sleep is causing these different outcomes. So that's an example of some of the research that I've been involved with. But from other studies that have used those experimental methods, we are pretty confident that a lack of sleep is associated with difficulties with your memory, difficulties paying attention, and also some interesting things like making poor food choices and going for unhealthy food when you go shopping and things like that. So sleep has a really significant impact on our health in lots of domains: our mental health, our quality of life, our cognitive performance, and in other areas. So that gives you a little bit of an idea of the kind of research you could do in sleep. But another thing I want to talk about relates a little bit to what Silke was saying about having a bed partner, okay? So most of us at some point in our lives, for quite a substantial number of the nights we sleep, will sleep beside somebody else, okay? So when you're taking your marriage vows, instead of for better or for worse, in sickness and in health, it should be something like in poor sleep and in bad, you know, whether you have sleep apnea or not, okay? That other person beside you in the bed has a massive influence on your own sleep. And what's interesting about the very limited research we have that has looked at the role of the bed partner is that relationship problems and sleep problems tend to happen suspiciously close together in time. So for example, if you think of a young couple who've just had a baby, that's a stressful event. their relationship might be a bit strained, and they're definitely not getting the sleep they used to. So that's an example of a stressful life event that could cause relationship problems and that corresponds with sleep issues as well. So although we don't have much research on this, it would be interesting to see more. So some research that we do have suggests that people, even when the partner is interfering with the sleep, are quite reluctant to give up sharing a bed with the partner. So that person you have in the bed beside you determines lots of different things. For example, it might determine the time you go to bed, right? I know when my husband's gone to bed, I'm like, I should really head to bed now. I'm never going to be able to get up in the morning. They might also determine the time you turn the lights off, okay? Because one of you wants to go to sleep and the other one wants to read, you're going to have to resolve that in some way. And they'll also probably determine the time the alarm goes off in the morning. So unlucky for you, if you're the one who gets to sleep in, you're going to be woken by your partner's alarm. So that person you have in the bed beside you has a massive impact on your sleep, and we don't know so much about that, except that it does have a big influence. Now, what's very interesting though is how reluctant people are to give that up, okay? So even though it might have negative effects on sleep, people don't want to sleep in separate rooms. They see sleeping beside somebody as a really important part of the relationship. So the majority of people won't take that step to sleeping in separate rooms. And indeed, sleeping in the same room might promote relationship satisfaction. So even though you might think you'll get a good night's sleep if you sleep separately, actually you may not, because you're missing that closeness of a relationship. So that could cause other problems. So even though both members of a couple tend to have marginally poor sleep together, once you're together, you're kind of stuck together. If you separate, it's not going to be that much better, okay? So that's one area of research that psychologists are getting more and more interested in. So I've talked a little bit about how psychologists conduct research in sleep. We ask you questions about quality and quantity. We might get you to fill out a diary. We might also, if we're really lucky, get to restrict your sleep, okay, and wake you up really early and see what that does, okay? So if there's any volunteers, okay, I'll leave my number with Craig. You can come up to the lab. I've also talked a little bit about this really interesting area of co-sleeping in a bed partner. And the next steps in research in psychology are probably to do more experimental studies. So instead of just asking people about sleep, trying to actually manipulate their sleep and see what happens. And also to better consider the role of the bed partner in terms of its effects on sleep. However, what I think people might also be interested in hearing about are how a psychologist would approach treating sleep disorders. So if you remember that book I had that has all these different diagnoses of psychological disorders, and insomnia being one of them. Well, psychologists are interested, of course, in treating this disorder because, the prevalence rates might vary somewhere between 10% to 1/3 of people at some point. So when a psychologist has asked you lots of questions to determine if you have insomnia as they would diagnose insomnia, so if you have what you think is insomnia and it doesn't bother you, that's okay, you don't need to come to us. If it's distressing, then you might. They might put a treatment plan in place. Now, although there's medication available for sleep problems, a psychologist won't be going down that route. First of all, we can't, okay? That's not what we're allowed to do. But also, we would like for people to have a healthy sleep pattern that doesn't rely on medication. And based on what I've told you this evening, having a healthy sleeping pattern could help you perform better at work. It might increase your mood, it might reduce risk of mental health issues, and it might even improve your relationship quality, okay? So there's lots of good reasons to want to do that. So a psychological treatment that psychologists use is called cognitive behavioral therapy, or CBT. So what's CBT? Well, the cognitive part stands for looking at how people's thoughts and beliefs about sleep and trying to tackle those and see if those might in some way be affecting your ability to sleep. For example, if you've had a few bad nights' sleep in a row, you might over time start to become a bit anxious about going to sleep, and you find yourself in a bit of a cycle of poor sleep, getting anxious about sleep, getting wound up about it, not being able to go to sleep, then I knew I'd have a bad night's sleep, and so on, okay? So part of the treatment will be about looking at that and seeing could we change that. Now the behavioural part would involve changing some behaviors around sleep. Now, although cognitive behavioral therapy involves lots of different strategies that tackle those things, obviously some of that would be with the psychologist, but there are still things that you all could do if you are having sleep problems. So I'm going to tell you what those are, okay? So besides talking to a psychologist, what might you be able to do? Well, if you think about it, as well as being a biological process, sleep is a habit. So you need to mind your sleep the way people tell you to eat healthy food, to get physical exercise, and so on. And what is really interesting about sleep is that although we are all great, okay, at putting a baby to sleep, or telling kids that it's a school night and it's your bedtime, we are terrible at going to sleep ourselves, okay? We like to stay up late watching Netflix, we take a glass of wine before we go to bed, we go to things on Friday night in the little theatre and we're going to be home late. So we do all these things and these don't help us with our sleep. So what you need to do is make sleeping well a habit. So what specifically do I mean by that? Well, the first thing you could do is keep your bed for sleeping. Okay, so a learning psychologist would say that you will learn an association between the bed and being asleep. And if you are reading lots in bed, or if you are spending lots of time in the bedroom and it's not about evening time and sleep time, you're not going to learn that association very well. Okay, so bedroom is for sleeping in. Okay, that's what that's for. Now, the second thing you might do is when you wake up in the morning, get up and get out of bed, okay? So we're all very tempted to hit snooze and kind of drift, okay? It's Saturday, it's Sunday, I'm probably going to do it tomorrow myself, okay? But I should know better. I should get up and go. And if you get up and go, your drive to sleep later in the evening will increase. So they are two things you can do. You can keep your bed for sleep, okay? You're not going to read a book in bed, even though that's not the worst thing you could do, all right? That's your smartphone, okay? And you're also going to get up in the morning when you wake up. Now, another thing psychologists would say, and that they would administer as part of the CBT program, would be to engage in relaxation. So they would say activities like meditation or yoga could be really beneficial. Now, if you wouldn't have time to go to a yoga session every week or to meditate every day, because we're all busy and we're running around and so on, you might see is there a few minutes at a few times in the day where you could take a few minutes to relax. So that could be at lunchtime. Go for a walk for a few minutes outside if you're lucky, okay? Or when you get home from work, take a few minutes to yourself before you launch into doing the cooking or whatever it is. So take a few minutes, just 2 to 3 minutes, a few times a day to help you relax, and that is going to have an effect in conjunction with all those other things on your sleep behavior. So there are a few things you can do, but the last thing that would be part of a program psychologists would give you, so the only thing you're missing is an actual psychologist talking to you about your beliefs about sleep. The last thing you could do is maintain what we call good sleep hygiene. So I don't mean you have a shower and you're nice and clean before bed. That's good as well, okay? And your bed partner may thank you, okay? But what I mean is having good sleep habits in terms of having a bedroom that's dark. Okay, so you're not going to have all the lights on. That's not going to be helpful. Maybe don't go for a run just before bedtime because you'll be a bit wound and you won't be able to sleep. Try not to take lots of naps in the day if you're having trouble sleeping at night. So all of those things, and maybe avoiding things like caffeine and alcohol just before bedtime, they are part of good sleep hygiene, and that's something else you could do to improve your sleep. So they are 4 tips for you. So if we remember them, there's a test. No, it's not a test, okay? Your test is tonight when you go home, okay? They would be to have your good sleep hygiene, your relaxation, to not spend time in the bed when you wake up in the morning, but to get up and go. And also to keep that the bed is for sleeping in and try and maintain that. So no time reading, or definitely not on your smartphone. And those things in combination over time are usually used to address insomnia. Okay, so I've talked a little bit about a psychologist perspective, probably quite different from a biomedical perspective. But what we're going to do now is I'm going to finish up, so hopefully you'll remember. Psychologists would say you remember the last thing you hear, so hopefully it's the tips, the first and last thing. And I'll hand you over to Craig, and we'll see if you guys have any questions.
What does science have to say about people who can survive in 4 hours, like Margaret Thatcher, and do you need less sleep
There is a variety. I mentioned it in my talk. I mean, some people just function on very little sleep, and that's fine. In general, and there's a big interest at the moment in sleep medicine, is that in general, too short sleep and also too long sleep is bad, and for many aspects, and that's from a psychological aspect, where a big aspect at the moment is to metabolic diseases, diabetes. So in terms of these risks, they increase in people who have little sleep and also in people who have long sleeps. So on average, we would recommend to have an 8-hour sleep. But there is variation, and some people just are perfectly fine on 4 hours. In following Ann Marie's talk, I actually was recently a patient where he was sitting in front of me. He was having 4 hours sleep and he was perfectly fine, but his wife was sitting beside him and said, you have to do something about him because he's going to bed with me at the same time and then he doesn't sleep. And he didn't actually have any problem, and he was way over 80 at this stage. So he obviously did something right. So there are variations, but in general, too short sleep and too long sleep is bad for you.
Just when you were talking there about having your child having the tonsils removed, well, I have a girl that's 15, and I always firmly believe, from a mother's point of view, we never got her tested or anything, that her oxygen levels wouldn't be quite up to par, like what you were saying in your slide there, because she suffers from allergic retinitis and her nose, so she's constantly, and when she sleeps, it's like that she'd be jerking in her sleep. She doesn't get a deep sleep during the night, so then she'd be around this time of the evening, or she'd be thrown out from the couch, like Saturdays and Sundays she just has no. But when she was playing sport, she would give 110% to the sport, but for the 3 days following it, then she would be just down. So I was just wondering, is there anything?
Yeah, I mean, this could well represent sleep apnea and nasal symptoms, and particularly in terms of allergic rhinitis, so, congestion of the nose is extremely common. Now, it's never and rarely, particularly in adults, the cause of sleep apnea per se, but it can contribute and can make sleep apnea worse. We all probably have scenarios when we have a cold and we suddenly realize that we actually snore at these nights, and many people will actually truly get apneas during this time, and it can certainly, even the snoring by itself, lead to worsening of sleep. So how to treat it is often very difficult. I mean, obviously it's very important to make sure there is no more severe form of sleep apnea behind it, so it may need to be discussed with a general practitioner. Quite often something like nasal sprays which contain corticosteroids to reduce the inflammation in the nose can help in these scenarios, but often, and particularly at this time of the year, very difficult to treat.
Actually, I think she mentioned that if somebody has sleep apnea, is it possible that they actually have a fit for their respiratory center kicks back in, or is that a different?
You mean a seizure as a fit?
Just start jerking in the bed.
Yeah, I mean, these jerkings are very common, and this is predominantly just in type of arousal. You see this actually a lot. Patients actually jump around, and that's quite often what disturbs bed partners as well. They are not true fits, they are just states of arousals and coming into a very light sleep. Patients are, by the way, generally completely unaware of these episodes. They are not generally waking up. It's actually rare that you have patients who truly wake up. Sometimes you have patients who complain of having choking episodes during the night, but this is actually the minority. And these choking episodes are not true fits as such, but you can get true seizures from apneas as well, but this is rather rare and happens in very severe cases.
Is there any place for the strap around the back with protrusions on from sleep apnea?
Which keeps you on the side?
Yes.
Yeah. Yes, a bit hesitation, as you see. It is intriguing, an intriguing treatment. In fact, we know that patients who sleep on their back, their sleep apnea gets worse. And that's just purely by the fact that with sleeping on the back, your upper airway gets smaller. You get additional pressure from your body, which is compressing on the upper airways. And hence, people get generally worse sleep apnea. And there is truly a phenomenon where patients only get sleep apnea when they do sleep on their back. So it is an intriguing concept, and to believe that if you keep people on their side, that this will improve their sleep apnea. However, this is not good for generally maintaining sleep. We do turn for a reason. We do turn for a reason to avoid pressure sores, and if we do restrict it from this turning, we also automatically wake up. So it's not a good treatment in promoting sleep. There are some more modern treatments which are following the same principles, or little magnetic devices. So they realize that if you lie on your back, they give a little signal and a little vibration. It's the same problem. Now for some patients, and particularly if the sleep apnea is milder, that is a solution. But generally, and for more severe sleep apnea, I would not recommend to go down that road.
I was surprised that psychologists don't recommend reading a book in bed at night.
Well, it's not the worst thing.
Yeah, well, no, because one of the things that certainly, from my own experience, that might keep people awake is that they're trying to solve a problem, or they're planning for something that's taking place the next day or whatever, and they can't kind of switch off their brain from thinking about these things. So reading a book can distract you, and then you'll fall asleep.
Yeah, if your mind is wound, it's impossible to sleep, right? So a psychologist would say, okay, don't go to bed then. Get back outside, read your book in the living room, and then head back to sleep, okay? So you're right that a book or anything like that, when I was a child, all I did was read before going to sleep, and it helped relax me before bedtime. So it was like relaxation and distraction from whatever you're thinking about. But if you're having a problem sleeping though, and you are reading, that could be something you could drop. Now, if you're reading and you have no problem, then that's fine. Does that make sense? So it can distract you, but for other people who have trouble maybe, it interferes with that association of bed as somewhere to sleep, because it becomes bed is somewhere I read, or bed is somewhere I watch TV on my laptop, or, and so on.
And it's really interesting, I suppose it ties in with the idea of developing good sleep habits and a good routine and good sleep hygiene. And I suppose if you are having trouble sleeping, cutting out the things that are maybe interfering with you moving into that place. And one you mentioned, you kind of started talking about medication, and a lot of the population self-medicate with alcohol. And I suppose the logic might be that I have a glass of wine before I go to bed, it makes me sleepy. Why is it a bad idea to have alcohol before you go to sleep?
Well, it might make you sleepy, but you wouldn't want to rely on alcohol ever as a medication. I mean, if you you feel like having a nap in the daytime, you're not going to take a glass of wine or a shot of something before bedtime. So alcohol you need to digest that. So you're giving your body lots of work to do, basically. So that's one reason why it wouldn't be a good idea. And it's also, in our model or a manual of different psychological disorders, we do have a category for substance or medication related problems. So people using medication or a substance to monitor their sleep, they may not really be addressing the problem, but they might be developing a different problem, like substance abuse.
If I just can add to that also, I mean, I mentioned obviously that alcohol or sleeping tablets, if I just put in for one time in the same category, can make sleep apnea worse, but another effect is obviously they also change the sleep architecture. So they do change the sleep architecture, which Craig presented with the light, deep, and the Rem sleep. This has also been affected by these substances, and that's not good. And not to forget also the hangover effects. So they can make sleepiness during the day worse. So in terms of chronic insomnia, it's really dangerous to actually have these long-term substance abuses. Now, however, if there is an acute event, so bereavement in the family, something which is an acute event which stops you from sleeping, these medications can help. Now, alcohol is really not the answer, but sometimes a short-term course of a sleeping tablet can certainly help. But in the long term, very little effect. It makes you tolerant to it. It's got addicted to it, and it doesn't really solve the problem.
And I suppose from a biology perspective, to complete the picture, is you'll spend much more time in phase 2 sleep.
Yeah.
So, in fact, what you're doing is sedating yourself rather than putting yourself to sleep. So it's a little bit like an anesthetic. You don't get into the REM sleep, or you don't have as much REM sleep after you've got alcohol in your system, and effectively you're interfering with your brain's memory forming ability and memory processing ability. Lots of hands. Yes?
What would you recommend someone when go to bed and fall asleep fairly quickly and wake up after maybe 2.5 hours, and then morning, you're about too tired to get up.
Well, that could be insomnia. So insomnia disorder would be difficulty falling asleep, initiating sleep, or difficulty maintaining sleep, or issues with waking up too early and not being able to get back to sleep. So if somebody had that, and if they had it 3 or more nights a week for more than 3 months, they would be classified as having an insomnia disorder. So a psychologist would recommend probably CBT, and they'd recommend lots of the different strategies I talked about, because they claim that they all work well together. But I think that would be kind of serious if that was ongoing. Now, if it's only happening for a couple of weeks because maybe you have a lot of stress at work or something's going on at home, you know, once that environmental trigger is gone, things should go back to normal.
You
But
don't recommend getting up after a couple of hours.
well, I suppose if you're happy to get up and feel you're refreshed, great. But if you don't, that would be a problem. Yeah.
I think it goes back to, as you said, when you were describing the diagnosis of insomnia, it's only a problem if it's impairing your function. So if you feel like you're sleep deprived, if you have this kind of jet lag feeling where you're in this haze of not able to focus on things, and we're all familiar with it. So if you find that, you know, when you get, if you're sleeping like that and you're having that during the day, then it's obviously, it is an issue. But we're told Margaret Thatcher functioned 100% with 4 hours sleep. Yeah.
Would it be a menopause thing? Because it seems to affect women really in their mid-50s onwards.
Well, I suppose insomnia can affect, you're saying yes, it would, Silke?
Yeah, oh yeah, that is, I mean, yeah, it is proven. I mean, and that's just the hormonal changes. So progesterone, which is one of the hormones which is changing in this time, is a big awakener. So there is a medical reason for having sleep problems in the menopause. And some people have really difficulties afterwards to adjust to these tissue issues afterwards. So yes, I mean, obviously it doesn't happen in everyone, but it can be a trigger. And by the way, menopause also then makes sleep apnea worse, so whereby women are generally protected before the menopause of getting sleep apnea. No, I mean, there is a barrier, and particularly when, you know, in setting of obesity, people can get it obviously before the menopause, but after menopause, women will very quickly pick up with the incidence in the same way as men have sleep apnea. So lots of sleep can be changed with the menopause.
And I'm probably the least appropriate person to answer or try to answer this question, but I did come across something that was suggested, and again, it's kind of relating the biology. When we fall asleep, when we're going from our wakefulness period into our sleep period, our body temperature is at its peak, and then it starts to cool. So contrary to what a lot of people turn on the electric blanket and say, I'm going to get nice and toasty warm and I'll fall asleep. That's counterproductive. In fact, what you should have is a cooler environment, and that will promote you going to sleep. So as most of us know, during menopause, there's a difficulty in regulating body temperature, and sometimes hot flushes and an elevated body temperature. So actually by, I suppose, making a conscious effort, or I've seen suggestions that making a conscious effort to regulate the body temperature more appropriately or to closer to the baseline might help just in getting off to sleep. Like I said, I'm not the most appropriate person to answer your question, but it's something I came across. Yeah.
With the different lifestyles now, some people are eating late in the evening. Would that have a bearing on the quality of sleep that you'd be getting?
Yeah, well, if your body is doing things like having to digest your food, it mightn't get as much of a chance to basically start sleeping. So digestion is a biological process, so maybe Craig would be the best person to answer that. But I probably wouldn't eat a big meal before bed any more than I'd have a glass of wine or a cup of coffee just before bed.
Yeah. So I suppose from a biology perspective, I talked about a circadian rhythm. And a circadian rhythm is not just about our body being able to tell when things are going on. It's about our body being able to anticipate what's going to happen next. So our body, our metabolism has evolved to expect to get fuel at certain times during our period of activity. And if we give food to the system when it's not expecting it, that can dramatically change and have lots of bad effects on your metabolism, number one, and knock-on effects then to disrupt your sleep, because your body is being forced into an inappropriate phase of activity that shouldn't be happening just before you're trying to go to sleep.
Particularly where there's sort of 3 or 4 cycle rotating shifts, or the sleep patterns are changing every week.
Yeah, so just for at the back, the question is about shift workers and changing patterns every 3 or 4 weeks, and that is a beautiful question because it gives us lots to talk about.
Okay, very short answer from the medical prospectus: shift work should be forbidden. It's truly a really big problem, and it's all about the circadian rhythm, and it's particularly affected for people who change their shifts a lot. So it's less so a problem, for people who do very regular shifts, and some people again can function a lot, but in general, shift work is the worst thing what we can do for our body clock. Going to bed at the wrong time, usually don't sleep that long, when particularly people on the night, and then sleep short hours, very disrupted sleep in a noisy environment, quite often interrupted by people who don't work shifts. So it should be forbidden. And in fact, actually, if patients have true sleep disorders and their shift work, we quite often have to write letters, and promoting that these patients should be moved to a different work environment. Bus drivers is a big problem. They work completely inappropriate hours very often, and from a sleep perspective, and particularly the consequences which can arise from bad sleep are obviously manifold.
And I suppose to expand on the circadian rhythm aspect of shift work, there was for quite a long time a misconception that our rhythm was relatively adjustable or modifiable, that you could shift your body clock quite easily. And we know now that's not the case. It can take up to 10 days to a fortnight to shift your circadian rhythm by even 1 to 2 hours properly, to actually change and adjust your whole circadian rhythm by a couple of hours either direction. So obviously the notion that you can flip it back and forth during shift work every 2 or 3 weeks and completely invert it, it's nonsense. Yep.
I was just interested in the idea, maybe you can comment on it, on the concept that sleep patterns change as we go from babyhood, small children, older children, adolescents, teenagers who seem to sleep an awful lot, and eventually then we transition into adult patterns of sleep. Is there a natural rate at which that, obviously babies sleep an awful long time, then smaller children progressively shorter, and then teenagers go back to long periods of sleep, and then adults. And I suppose if there's a question in there, do teenagers actually need more sleep?
Yes.
Short answer, yes.
Yes.
Leave them
Be
alone,
nice to
let them
them. School should start later.
So,
is there a natural rate at which...
okay, I'll start skinning the cat. So, yes, for those major periods that you outlined, there are dramatic changes in how we sleep. A baby can sleep up to 16 hours and 24 hours, and that's perfectly normal and natural and necessary. And they are, for a lot of the things that I mentioned, like restoratives and all the growth factors, a lot of those are produced during phase 3 sleep. The growth hormone is kind of at its peak production levels. The brain processing, the memory processing, children obviously are learning lots. They have a lot of memories to cycle through. So that Rem sleep is very, very important. Teenagers are interesting because we just talked about shift workers and the circadian rhythm being shifted. And it seems that naturally, because of the hormonal changes that happen during adolescence, teenagers, their rhythm is offset from both adults and children by a couple of hours. So their natural sleep cycle would actually hit between 12 midnight and 10 a.m. And that's normal. And there are actually pilot studies in the UK changing school starting times. There are schools that are trialling this in the UK at the moment, so that secondary schools will start at 10:30 a.m., which will be just the right time for teenagers to be engaging and be most active, and then they'll run longer during the day. So maybe I'll throw over to somebody else for comments on.
Yeah, well, I think that's a really good idea, because we're trying to force, just like we're forcing shift workers into working a pattern that doesn't suit, we're trying to force teenagers into a pattern that doesn't suit. And seeing as most people go to secondary school when they're teenagers, we have a whole new system, so why not shift that? So maybe we should work around what's healthy rather than what's convenient. Maybe in years to come we'll look back at that and think it's the same as, you know, working night duty one night and day during the next day.
It just occurs to me now, is there a difference between sleep apnea in terms of the long-term effects in a teenager versus an adult? So if it's diagnosed that it is, I suppose, the 40% that's not related to obesity, is there, I suppose, are there added effects or added negative effects for teenagers if it's untreated as opposed to adults?
We don't know is the short answer. Even the effects in children on sleep apnea, and they're usually, if you don't take the tonsils out, they generally grow out of it for a while. And we thought, okay, well, that's okay. But there is new evidence now indicating that these children indeed may actually have long-term problems, behavioral problems, and particularly from their lack of sleep in childhood. But we don't know an awful lot about it, of how long you need to have sleep apnea before it relates to consequences, and it probably varies from person to person. Other influences in the environment are important to this as well. So we don't know, in fact.
I think there is that some children with symptoms of ADHD, when they have the sleep apnea disorder, the symptoms of ADHD.
Yeah, we talked about this actually early on, absolutely. And it's quite plausible when you think, you know, they're lacking oxygen at night. So, I mean, what this is doing to the brain, I mean, the whole mental aspect of sleep apnea, this is really under intense investigation at the moment, and even things like Alzheimer's, they're probably related to sleep apnea as well, and it's all that the brain has to work in a very different way, has to function on much different oxygen levels, and oxygen is important.
At the back.
I just continue to the teenage theme and small children theme. I brought them with me. I just wanted to ask, and I suppose it's kind of a modern day phenomenon. You mentioned smartphones earlier, but to what extent do they disturb their sleep? Like, obviously we all agree now that they're not a good idea, but in terms of having children, and there's no avoiding them now, they use them for school. At what cut-off point, for teenagers, should you be saying, well, look, probably not a good idea? And then the second part of my question, if you have a child that doesn't sleep, is finding it hard to wind down, and you've ruled out all of those, I suppose, in the old days, in my day, it was a glass of milk. So from what you're saying, is that a good idea or a bad idea? For example, obviously you're not going to give them a glass of wine, but something like, you know, we're told there's something in there that might promote sleep, or is the body seen as a form of energy, and then that is the purpose?
So on the light aspect, and that goes directly to the biology I talked about, so one of the most potent stimuluses for our SCN, this clock in our brain, is light hitting the eyeball. And we know that, I don't want to go into too much detail, we know that, now we know, we used to think that it was the same cells that we used to see things. So our cones and our rods, which are what allow us to see things. But we now know that that's not the case. So a blind person that has no perception, has been blind since birth, they can still have a perfectly synchronized circadian rhythm. So they are different receptors. And they are tuned very, very specifically to the blue part of the spectrum, or blue light. And as circumstance would have it, all of the technology in our homes, smartphone screens, LCD screens, and LED screens generate blue light. So they're actually, by accident, designed to give the real wrong type of light in terms of stimulating that part of our brain. So as a rule of thumb, it's not practical. As a rule of thumb, I suppose the academic answer would be that if it's not bright outside, you shouldn't be exposing yourself to blue light, because you're automatically going to start messing with your circadian rhythm and therefore your ability to go into a sleep cycle. That isn't practical. We all watch television in evening time. But what I use, and it's completely anecdotal, there's no science behind it, in my house, an hour before bedtime, screen's gone. It seems to work in my house. So we have a 9 o'clock is our curfew. 8 o'clock, the two kids go cold turkey from either television or they go and they play in the playroom, or they read a book, or we read them a story or whatever. And again, it seems to work.
What about the milk, though? No?
So dietary melatonin.
Oh, you're avoiding them. Okay.
So it's kind of veering into the area of dodgy medical and scientific. So you can supplement your melatonin levels in a dietary supplement. So it's not a medicine, but you can buy it in a health food shop. And again, the Mayo Clinic will tell you that some people report it helps. But you should talk to a GP before you go down that route, I think.
It might also just be a placebo effect. So here's something I'm telling you will help you go to sleep, and it will help you go to sleep. And that's the case even when you know it's a placebo. If you give pain patients a drug and say this is just a placebo, they'll still report an improvement, most of them. So it could be that either.
Yeah.
I have something in defense of technology. And smart
Go for it. I love technology.
So as a cranky morning person who considered myself having bad night's sleep, I bought myself a Fitbit
Excellent.
that monitors sleep, and it will tell you whether you're tossing or turning and how many hours you've got. Anyway, and then in the morning you can check on your phone and it will tell you, give you a star actually, which makes you great. Congratulations with 8 hours sleep. And I found that I don't toss and turn as much as I thought I had. But when I do get the star, I'm in great form all day. Now, sometimes I don't get the star. It is a placebo effect, or it's a psychological trait, but
Well, it's like when you got a star in primary school, you know, that actually would give you an effect, because you're like, I'm being told I had good sleep, so I believe it, and off I go. And my school, we only got like a spota jarag, a red spot, because we didn't have the money for gold stars, okay? But the same idea. So it could be not only that you are getting good night's sleep, but that you're being told, and it's changing your beliefs about sleep and your ability to cope with whatever is coming as well.
I mean, these devices are actually incredible. Now seeing it, I mean, as a sleep physician, we do a lot of what we call sleep studies. So we put patients and monitor their sleep in all different aspects overnight. And to monitor sleep and to define if patients are on light sleep, deep sleep, and so we put 16 electrodes on the head. So if you think that such a thing can replace this, obviously not. So, I mean, my husband has a similar device, this Microsoft Band, and it tells him even deep sleep and light sleep. And I also tell him that's a bit rubbish. I mean, you
give him a gold star.
It's actually not completely rubbish, because it does monitor movements. So, but it's wrong perception to think that in deep sleep you don't move around. That's not necessarily true. But if it helps, you know, anything, you know.
Something, just a quick straw poll as well, while we're on the talk about movement and sleep. Has anybody ever experienced sleep paralysis? Yes. Can you tell us about it?
I talk about it. It's a few times actually, especially weekends when you sleep more than you should. It's something like a dream when you awake, but you can't move.
You would expect that about 15% will experience sleep paralysis at some stage. So I would have expected probably a lot more hands.
Well, there was a few more hands at the back,
Okay,
so
good.
yeah, we had it more than one.
And in most people that have actually no relevance.
So sleep paralysis is, so during the 3 non-REM phases of sleep, our muscles are engaged, so they could in theory move. But during REM sleep, when our eyes are flying around and when we do most of our dreaming, our body actually disengages our motor center so that we are paralyzed. And it's thought again that it's an evolutionary adaptation to stop us from acting out our dreams while we're not conscious. Okay? So it's a protective mechanism that our body is not capable. So if we're dreaming that we're running away from a Tyrannosaurus Rex and that we need to jump out a window, we don't actually get up and jump out a window. So it's a really interesting phenomenon. And sleep paralysis is when people sometimes come to the surface. They come out of REM sleep and they come back to a period of wakefulness, and you don't get proper disengagement of that process, that intentional paralysis. And it can be very, very frightening. And it's thought as well, just again anecdotally, that is where the notion of alien abduction comes from. that people experience this waking and they've had a very traumatic dream and maybe their anxiety levels are high and then they can't move. And it used to be in the 18th century it was maybe a visitation from a ghost or an alien, or sorry, an angel. And then in modern society, it's become aliens. So that's just an interesting aside. Yeah?
I am a young teenager, and for many, many years, so I could be going 10 years anyway, the child wakes up, takes forever to go to sleep. Maybe after 2 hours wakes up, will walk into our room, say goodnight, wake us up, and then walk back to their room and go back to their bed, take some time to go to sleep. This has been going on for years, and in the morning, maybe you can see in their demeanour they're not well slept. Functions normally, behaviour great at school, doing fine at school. What is that?
Are they conscious of that? Do they remember coming in and saying goodnight to you?
At this stage, yes. Possibly not when they were much, much younger.
Right.
At this stage, yes.
But it is, they can remember it the next morning.
Yeah, absolutely. And apologise.
That's important.
That falls more into your, this is actually not a sleep disorder. It is a sleep disorder, like sleepwalking. If people cannot remember what they're doing, they do it completely in their sleep. It's generally sleepwalking, but this is really where there is no recollection of the event whatsoever. It's a typical teenage disease, and generally teenagers, they will grow out of it. And if nothing happens and people are safe, then we generally don't interfere with it and let them go out. If they are conscious within these episodes, then they're kind of dream walking, which is not as such as a sleep disorder.
And it may be...
maybe there is also subconsciously still something going on, problem of our society, that we don't really empty our brain before we go to bed. So we need help from Ann Marie then in this case.
Did you want to say something?
No, I was just going to say, how long did you say? About 2 hours?
It takes forever to go to sleep.
Yeah.
And then maybe fall asleep for 2 hours.
Okay. So what it may be, and this is pure conjecture, so that cycle we talked about, this phase 1, phase 2, phase 3 in Rem sleep, that just doesn't just happen once. That happens 5 or 6 times over the night. And a full cycle of that to go from phase 1 all the way to the end of your first REM sleep takes about 90 minutes to 2 hours. So maybe there's something there that the child is actually waking up, the teenager is waking up at that stage. And maybe it's just habit at this stage, that they're waking up after the first... Well, maybe if they're having a full cycle of sleep. So we now know for power napping during the day that there are optimal times based on that pattern. There are bad times to wake up in that pattern and there are good times to wake up in that phase. And that's not a terrible time, 2 hours. You've probably gotten a full cycle of sleep. And then if they can get back to sleep and continue on and get the rest of the cycles they need, again, it's speculation.
And if they're doing well in school and everything as well, if it's not causing any distress. I also wonder about them knowing it happened, because they know this happens. You know what I mean? So when I was a child, I used to think that when they brought a life-size Gulliver to the beach where I lived for the festival and they put him there, and I used to think I remembered this, but I didn't. I saw a picture of it, So when you know something is happening, sometimes you can think you always remember it, but out of habit, maybe you just know that probably happened.
Okay. And just now that the person is a teenager, the child is a teenager now, should we be allowing them to go to bed later at night? Would that assist them maybe in staying asleep during the night?
The biology says probably.
Yeah, if they're spending that long awake before going to sleep, I would be inclined to do that.
Because they're probably going to bed too early for their circadian rhythm.
So happy to hear that.
Yeah.
But the key is that if you are going to extend bedtime, that you're not ending up with a very compressed sleep pattern. If you're getting up for school the next morning, so it's hard to.
If I can extend to this, something which we completely do wrong in our society is obviously having longer sleep on weekends. Ann Marie mentioned it briefly. Sorry, I see the disappointment here.
It's Friday, don't tell us on a Friday.
But from a sleep physiology aspect, we should have, and I mean, insomnia treatment is actually so to put a really regular sleep-wake cycle into someone. So you think, okay, I only get about 5 hours sleep during the week, so I make up for that at the weekend. It's the completely wrong thing to do. It is artificial sleep. You have a lot of Rem sleep, very active sleep then. So you're not making up by that, but you actually make things in terms of a sleep cycle even worse, and you really promote a poor sleep during the week then again. So ideally, right, and I'm not at all saying that's what I'm doing, but that's what I should advise, is that we have our 8 hours sleep, go to bed at a very regular time, get up at a regular time. If it's Saturday or Sunday or Monday, has no difference.
It's the same as food, I suppose. You know, you don't eat extra. Well, you probably do eat extra on a weekend, but we know we shouldn't.
What tests do you carry out in order to diagnose the sleep apnea, or is it all cholesterol from the?
No, not at all. I mean, the history is very important, and it's really the A&O of anything we do in medicine. But to diagnose sleep apnea, you need an overnight test which detects these breathing pauses. So in general, this is some form of a sleep study. There are very different ways of how a sleep study can be performed. It can also sometimes be performed at home, depending on the scenario and on the equipment which is available, but it will require an overnight confirmation of these breathing pauses happening.
So I'm acutely aware that we are currently interfering with everybody's potential to move to a sleep period. So we're going to take 3 more questions.
Just, you were talking there about blocks of sleep. I have disturbed sleep every night. What's the length of block sleep that will give you enough? Like, I would sleep for, say, 3.5, 4 hours, wake up for 2 hours. I'd have to get up and read, fall asleep in a different bedroom, and maybe get another 2 or 3 hours. Is that enough good sleep to get me the cycles?
So I suppose it's subjective. Do you feel like you're getting enough sleep?
I wake up every morning and I'm as bright as anything. Come 9 o'clock every night, I'm tired again.
But that's perfectly healthy. That's perfectly healthy. Everyone do what this lady does. Right here in the middle.
You mentioned there in passing power napping. Is that a thing, or hopefully in 10 minutes rubbish?
So I can't say it's a thing because it hasn't been properly studied, but I suppose there are. I know that if I can only sleep for a short period of time, that I'll go without that sleep rather than. So if I have the prospect, say, of napping maybe for 45 minutes, something like that, I won't, unless I can sleep, more than 90 minutes. I'll feel worse because you're going to wake up in the middle of the cycle. So the idea with power naps is that you can roughly, if you say that you get a full cycle in, a 90-minute cycle in, or even the first phase in 15 minutes. So there's you'll find them online, there's recommended 15 minutes or 45 minutes or 90 minutes. And if you can't do one of those, don't do any of them. Now, there's very little scientific investigation, but that sort of stuff is out there. You can, I suppose, rationalize it based on the biology, but there's no conclusive evidence about it.
That's good enough.
Off the back.
Hi, is there any relation between the SCN and the pineal gland?
Yes, there is. So again, and it links very much to what we were talking about, the restorative aspects of sleep. So the pineal gland and the pituitary axis, the SCN, there's a hypothalamus pituitary axis, which is very, very active during phase 3 of sleep. And it stimulates its kind of peak growth factor production, human growth factor production for developing, so children, adolescents, and teenagers. So yes, there is definitely an important link and an important component, a physical link. And there was one more down here. Was there? No? Have we exhausted all the questions? One last one.
Yeah, no, the 3 speakers seem to be of the opinion that psychological treatment such as CBT is better than using medical prescriptions. So why are sleeping tablets so widely prescribed? Is it a compliment?
Well, first, I'm not anti-medication. I suppose I would support using it appropriately. And I think sometimes we see it as a shortcut, you know, like, oh, I had a few too many drinks last night, I'll take some Nurofen and then I can do it again, okay? So that's where I'd be coming from with it. I think more and more and more in society we want a pill for things. And we don't even just want them for things that are wrong with us. We want pills to make us brighter or to pay more attention. Students are on medication now so they can do more studying. So I don't think it's specific to illness. What do you think, Silke?
Yeah, I mean, absolutely, they have its merit, and particularly in the short term, and to solve issues and to help people to sleep who have an acute problem. Sleeping tablets can be very valuable. I mean, people come into the hospital in an environment where you generally never sleep, lots of action going around, you take a sleeping tablet, that's perfectly okay. In the long term, they do have a lot of problems. Why they are so widely prescribed in Ireland is an Irish problem. In other countries, it would just simply not be possible. Like in the US, for instance, if you fill a prescription as a physician for sleeping tablets, after 30 days, you will be given a call by the medical board to ask and to justify your prescription. That obviously doesn't happen here. So it is a big problem of over-medicating, overuse of sleeping tablets.
And I'd bring it back to talk about the fact that, to my knowledge, we do not have a drug that makes you sleep. We have a drug that sedates you. And we have lots of drugs that sedate you, but there's a difference between sedation and sleep. In sedation, you are like when you're anesthetized, you spend most of the time in, you know, phase 2 sort of sleep, or brain patterns that replicate phase 2 sleep. You don't cycle through the different phases, so you're not getting the benefit of it, so you're not actually properly sleeping, even though you might become unconscious quicker. Okay, I think one last question.
This gentleman actually has lifted his fingers a
I'm
lot
sorry,
of time. Yeah.
The light is catching my eye there. 2 more questions.
And you stop breathing, you know, snoring and stop breathing, is there ever a fear that you wouldn't start breathing again? Could you die?
Yes, however, this is rare. I mean, this is a question which I hear all the time. Do I actually wake up? And there's people who have such a very nice bed partner who actually don't go asleep in case they have to wake up their bed partner. Yeah, no, in generally our brain will function and will set in. However, in some very severe cases of sleep apnea, it's just as impossible to actually open the airway again by the brain, okay? So people, yes, do die in their sleep from sleep apnea, but this is a very rare phenomenon.
And now we're on to the last question.
In general, I could sleep through Ireland. My wife will tell you, if the last one go off, I could sleep for 24 hours, no problem. But I find I was in an outpatients department in one of the local hospitals Monday, 3 hours wait, and quite frequently just sitting there, fall off the go, oh yeah, right, get up, walk around for a minute or two, and sit back down, and grand, next thing, starting to sleep again. Sitting in the passenger seat of the car, driving along, less I'm in the driver's seat, and there's nothing particularly stimulating to look at, I'll just go, what is that?
Well, do you have sleep apnea is the next question.
But you wouldn't think so.
Yeah. I mean, everything what you have told me now could very well point to yeah. Now, important is obviously what I'm telling you. None of these symptoms of sleep apnea, and that's why the reason of actually bringing the patients and doing an overnight testing, none of these symptoms are specific, right? And actually patients, now snoring is a very dominant symptom in sleep apnea, and more than 90% of patients with sleep apnea have it. But then there's a 10% who don't have it. And they are quite often the ones who are actually more severe because they just don't have time to snore, because they're just keep stopping breathing all the time. So, I mean, none of these symptoms are specific. GPs and so, they would have a specific scoring system which makes them more likely to predict sleep apnea, and they will know when to refer patients on for further testing. The test for sleep apnea is very simple. It's not a big thing, and it can make a huge difference to actually determining what's wrong and also determining potential future outcome in life. I mean, obviously, we are all tired at some stage. Like, I'm tired all the time, but I only sleep. I don't want to mention at what time I raised my hand there, but I certainly don't get enough sleep, and as a consequence, I am tired at some stage. I have a reason for this, but it's also the question, is that just a short-term problem? Is it a long-term problem? There are other factors in sleep apnea which are important, like high blood pressure, which is very common in patients with sleep apnea. And then, as I said, the weight issue is important to look at. So it's not just the 3 symptoms which I just pointed out. There's a lot more to the story. But if you feel you're getting sleepy and you fall asleep in situations where you shouldn't, it might be worthwhile to have a chat with your GP.
Good, good. This is the only talk I've ever given where I feel slightly honoured that somebody fell asleep during. So with that natural end, I think we'll wrap things up for the evening. I would like you to join me in thanking our 2 visiting speakers. And I didn't mention at the start, but of course we are very grateful to the Little Theatre and to the team that run the Little Theatre for their generosity in facilitating us and giving us a wonderful, wonderful venue for this type of event. And we hope we'll be back again next year for another one, and that we might see some of you here again. And I want to thank you all for your participation, the wonderful questions, the discussion, because that's the most enjoyable part for us. And it's the part of the evening that I think everybody learns most from. So thank you very much. Thanks again to the Midlands Science Festival for running the event.